Hello, my name is Najib Taki. Welcome to my YouTube channel. Today I'm going to give a brief intro about how the JavaScript runtime works. So first of all, JavaScript is a single-threaded language that can be non-blocking. Single-threaded literally means that it can only do one thing at a time. That is to say, it has only one call stack, which we will discuss later on in much detail. There's a JavaScript engine that each browser executes. In Chrome, it's known as the V8. This engine reads the code we write and converts it into machine-readable language. It consists of two parts, that is the memory heap and the call stack. So now, the memory heap is where the memory allocation happens. The call stack is also where the code is read and executed and tells you where you are in the program. So with the call stack, let's say we have some piece of code. On the first line we have console log 1. On the second we have console log 2. And on the third we have console log 3, which we've entered into our JavaScript environment on the browser. So upon execution, the output we get is 1 on the first line, 2 on the second line, and then 3 on the third line in systematic order. So if you recall, we mentioned that the call stack is what reads and executes our script. So what it actually does here is that it reads the first line, this outputs 1, reads the second line, outputs 2, and then reads the third line and then outputs 3. Now, if you're a web developer, you might have heard of this website, Stack Overflow. Stack Overflow is actually a phenomenon that occurs when the memory heap of a stack overflows with some code such that it has literally no space left in store. Okay, so this makes sense. So basically, all of what we've said is that the JavaScript runtime, the JavaScript engine, works on the principle of first in, last out. That is to say, the first line of code is executed first, and then the second line of code is executed next, and then the last line of code is executed last. That is finally. But then when we need to do things like image processing, which take quite a long while to get executed, it's definitely going to be frustrating using the synchronous process. So this is where asynchronous programming comes in. So in asynchronous programming, we can do something like this. Something like adding a set timeout function. A set timeout is a function which allows us to create a timeout for our code execution. And we can give it a first parameter of the function we want it to run, and a second parameter of how long we want it to wait before executing that line of code. Okay, so in this instance, let's say we want to wait 5 seconds to run that line. When we input this piece of code into our runtime, what happens is that line 1 and then line 3, which is console log 1 on the first line and console log 3 on the third line, execute before console log 2, which is on the second line, does that exactly 5 seconds later. Okay, so what this process is basically what is termed as asynchronous programming. So in order to further understand this, we need to look at the next part of the JavaScript runtime environment. The environment doesn't only consist of the JavaScript engine, which we've already talked about, as containing the memory heap and the call stack. On top of the engine, there are extra things such as web APIs, a callback queue, and then an event loop. SetOutTime function, which we mentioned earlier, is one such example of a web API, which we'll look into much detail later on as we talk. It's one of the features, which is the web API, is one of the features the browsers actually provides us with, so we can successfully implement asynchronous programming. So using our previous piece of code where we had console log 1 on the first line, console log 2 on the second line, and console log 3 on the third line, what you are going to do now is to create one call stack, one web API, and one callback queue, just like we have in our JavaScript runtime environment. So first, we have our console.log that goes into the call stack, and that gets run. So it executes console.log to the browser. So now we then get the second task, that is the set timeout into our call stack, because we already executed the first task. So we are now going to move on to the second. And now, because set timeout is not part of JavaScript but only of the web API, it has a special characteristic. What happens now is that it triggers the web API and says, hey, set timeout. Because we notified the web API, we can pop it out of the call stack. Okay, so now, according to the parameters by which we defined set timeout earlier, we gave it a time of 5,000 milliseconds, which is equivalent to 5 seconds exactly. So it's going to know that in exactly 5 seconds, you have to do something. And because the call stack is empty, the JavaScript engine now goes to console log 3 and then executes 3. So now we've executed both lines 1 and then lines 3. But we still have the set timeout line to execute, which has to be executed exactly 5 seconds after. So after 5 seconds, when the time is up, exactly 5 seconds, when the time is up, the web API is then going to run the set timeout, which contains console log 2. So now the last part is the event loop. That's what we are going to touch on last. So the event loop over here is what now checks if the call stack is empty and keeps checking if it is empty all the time. If it really is empty, then what it now does is that it puts in the remaining line, that is the line containing the set timeout, which we set to 5 seconds, and then runs it. So when it runs it, the output it pops out is 2. So after this is done, it implies we finally run all the lines straight up from line 1 through to the third line. But in this instance, since it was asynchronous, we didn't do it systematically, as in the first line running, second line running, and then the third line running. But in this instance, since set timeout of console log 2 on line 2 was given a set timeout of 5 seconds, line 1, which is contained console log 1, and line 3, which contained console log 3, run first. So the output we now get is 1 on the first line, 3 on the second line, and then 2 on the third line. In which case, this 2 was run 5 seconds after the set timeout had, been executed. So this is basically how the JavaScript runtime and its components actually work. Yeah, so this is just a brief overview of how it all works. And in this video, I believe I touched clearly on memory heap, call stack, on memory heap. So like I said, I believe we've touched clearly on the memory heap, the call stack, web APIs, callback queue, and then finally the event loop. Yes, so thanks a lot for watching the video, and until then, see you next time.